Hello everyone. Okay, so in this video we are looking at the derivatives of exponential functions. So, the rules for exponential functions are very similar to whatever we've been doing all the time. What's special about an exponential function is its derivative is the same. So e to the x and derivative of e to the x is still e to the x, right? We just always have to remember now to multiply by the derivative of my power. So here we have e to the ax. So what we need to do is keep e to the ax as we do, but then we multiply by the derivative of ax, which is a. Right? And that's it. Remember, because this is chain rule. So we have like e to the u, y. So I'm going to differentiate this function with respect to u, then find the derivative u, and that will give me my dy x. They go on top of each other. So I need to find the derivative of my power. Multiply them. So differentiate e to the 5x, very easy. So my function will just be e to the 5x, easy. Multiply now by the derivative of 5x, just 5. So my answer is 5 to the 5e to the 5x. Stunning. E to the tan 3x, a little bit harder. So my function is e to the tan 3x. And now I need to multiply by tan 3x. Well, that is equal to sec squared x. And multiply it by the derivative of the angle in here, which is 3, because I'm deriving a trig function. So yeah, that's going to be 3 sec squared 3x e to the tan 3. And that is my derivative there. So they're like very, very easy, very straightforward. So we are going to look at some some not easier examples. Look at some more trickier examples that came up. So in 2008, we have the function y is equal to e to the x minus e to the power of minus x all over e to the x plus e to the power of minus x. So we need to show that the derivative is 4 over e to the x plus e minus x squared. So we're going to be using quotient rule because we're dividing. So this is u, this is v. My derivative of u is just going to be dx, that stays the same. Then it's going to be e to the minus x, but then I'm multiplying by minus 1. So minus e to the x times minus 1 is plus 1. Then the derivative here, dv dx, going to be equal to e to the x minus x. So now that I have my u, v, and dx, let's put it in. So remember, v, du dx minus u dv all over v squared. That is equal to e to the x plus e to the minus x times du dx plus e to the minus x minus u equal to e to the x minus e dx minus e. That is all going to be over v squared. So e to the x plus e to the x squared. So multiply at the top here. E to the x and e to the x is x. E to the x times e to the minus x. Well, that's going to give me 0. E to the minus x and e to the x is going to give me 0 because minus x plus x is 0. And e to the minus x times e to the minus x is going to give me e to the minus something. Here, now we're subtracting. e to the x times e to the x, so we're subtracting e to the x, minus e to the x times e to the x. Well, that's just going to give you minus e to 0, minus e to the minus x minus e to the x is going to be positive. Sorry. Boom, boom. Yeah, so sorry. Yeah, so e to the x, sorry, then minus e to the minus x is minus e to 0, minus e to the minus x times e to the x is equal to minus e to 0, minus e to the x times minus e to the plus e minus x. So I have this minus sign on the outside. That's going to be sign of x. That's going to be plus, plus, minus. So let's just sort out my numerator first. Well, e to the 2x minus e to the 2x, e to the minus 2x minus e to the minus 2x. They're going to cancel. So now I'm left with e to the 0, e to the 0, e to the 0, e to the 0. Well, anything to the power of 0 is 1. That's 1 plus 1 plus 1 plus 1. So I'm going to be left with 4 on my numerator, and my denominator is still going to be this whole thing. So my denominator then e to the x plus e to the x squared. That is, which is matches what they want up here. Stunning. Right? Now this one here, we want to prove that the second derivative is equal to the initial function. So let's find the first derivative. So, and we actually don't have, it looks like we might have to use quotient rule. We actually quotient rule, because this can just be written as a half times e to the x. Right. So this could just be a half, and the derivative of these e to the x minus e to the x. That is my first derivative. My second derivative is just going to be e to the x just goes to e to the x, minus e to the minus x goes to plus e x, x, e to the x over 2, which is my initial function. So if you use chain rule here, if you use quotient rule here, that is, it's just if I'm multiplying by a constant, I don't really ever need to kind of account that in the differentiation process. You only ever use like product rule or anything if it have like a constant in front. I can just differentiate bracket. That's it for X. Next video is our final video on differential calculus with differentiation logs. So I hope this video, and I'll catch you later. Bye.